This video is going to have a look at Python functions in the context of program design, and in the process we're going to introduce stepwise refinement and structure charts as a way of designing code, and we're going to see why a function is a useful technique. There are two popular design and coding paradigms when building software systems. We have object-oriented programming and object-oriented design, often abbreviated as you can see here. There is also procedural design and procedural coding. Python can support both these paradigms, both individually and as a mixture of both. This means we can build a software system that simply consists of lots of objects that message each other to perform particular tasks. And of course, this would reflect the object-oriented programming and object-oriented design way of writing software systems. An alternative is to have a procedural design and procedural coding way of writing your software systems, and this would result in lots of functions calling each other and passing each other the data that is to be manipulated when you perform the calls to the various functions. And in this particular approach to programming and designing, you would not have any objects present. In other words, you wouldn't be defining any classes from which objects would be derived. You would have what is frequently referred to as procedural design and procedural coding. Of course, you can also build your software systems using Python, whereby you have classes that you declare, create instances of those classes, i.e. objects, have those objects messaging each other, as well as having functions where functions call each other and pass the data appropriately. In other words, you could have your software systems with a mixture of both object-oriented approaches and procedural approaches to the building of the software system. This video is going to look at coding techniques that support procedural coding and design. In particular, it's going to look at the function. Functions are small programs that perform a specific task. There are benefits when programming with functions. Functions allow a program to be split up into small logical units where each unit performs a simple task. A program, i.e. software system, developed with functions is much easier to debug than a large monolithic program developed without functions. Imagine a computer program that has 10,000 lines of code, 10,000 program statements. You start at the first statement, it goes on to the second statement, all the way up to the 10,000th program statement. If you intended to understand what that program was doing, and it is your own program, let alone somebody else's program, you look at those 10,000 lines and it is extremely difficult to get to grips with what that program is about, because you just have one line following another. Now, I like to describe that as a monolithic program. Now, software systems are not built in this way. What happens is you actually decide, right, I'm going to write this bit of the code, and I'm going to have a function to do this, and I'm going to give the function a sensible name. So what you end up then seeing is a program with a call to a function, another call to a function that has a sensible name, another call to a function that you give a sensible name to. So now you see a pile of function calls that have meaningful names. Now, your software system is still going to be thousands of lines, but you're not going to see that as one monolithic program. What you're going to see is lots of calls to functions where those functions have got a sensible name, and you can then get a quick overview of what your program is all about. Of course, there are more benefits to using functions than what I'm describing here, but that's just a pretty straightforward and obvious one. It's far easier to read programs that are split up into functions. Functions are portable sections of code that can be used in other programs with little or no modification. They can act as building blocks for other programs, other software systems. So in other words, let's just say that you've been developing a software system and you have a function that calculates the VAT on goods. and you finish that software system, you release it, everybody's happy with what you've produced, and then you move on to a different project. And you suddenly realise, oh, I've got to calculate the VAT here. Oh, I've already got a function somewhere to do that. I'll use that one. You don't have to write another one. So you build like a collection of functions that can be used in all of your software development programs in the future. Oh, by the way, if you were wondering what VAT was, it stands for Value Added Tax. It's a form of purchase tax. So if you were told something was £100 and it carried a VAT rate of 10%, then it would mean you would have to be paying £110 for that particular item. Let's design a program to calculate and display the net pay and name of every employee in a company. The first thing I would do in these circumstances, if given this particular program to design, I would want a top-level view of it, a top-level design. And the design I would come up with would look something like this. And we can see I've numbered all of the lines. If we look at the first line, we can see that says, while not the last employee record. In other words, what I'm going to be doing, I'm going to be looking at each employee in turn, and for each of those employees, I'll be doing these 3 steps here, steps 2 through to 4. And have a look and you can see that they are indented, suggesting that they are inside a loop. And that's exactly what I'm thinking I'm going to need here. I'm going to say, right, I need a loop that's going to go round and perform these tasks for every employee in the company. So it might go round 50 times if there's 50 employees, 100 times if there's 100 employees, and so on. If I look at step 2, it says obtain the employee record. Doesn't say how I'm going to do it. Doesn't going to say whether it's coming from a file, but I know that's what I have to do. If I look at step 3, it's saying calculate the pay. It's not breaking it down in any way. It's just saying that's what I'm going to have to be doing here. I'm going to have to be calculating the pay of the employee. And then the next line is print the wage slip. So I would display on the screen for this particular program, that's what I'm going to do. I'm not going to be sending it to a printer because you're looking at a screen. I can't show it going to a printer, can I? So if we stop and reflect on this, those are the bold steps for my design for my particular program. Now, those steps are fine. It allows me now to concentrate. So I'm not going to concentrate on all of the steps. I'm going to have a look at step 3 where it says calculate the pay. And I'm going to say, well, what will this involve? And what I'm going to have to do is refine step 3. And you can see the refinement of step 3 is actually shown here. And what I've now done, I've labelled this as 3.1, 3.2, 3.3, emphasising the fact that it's a refinement of step 3 of the top level design. And you can see that it says calculate the gross pay, then calculate the deductions, then calculate the net pay. Now that's the order I would have to do it, because if I calculate the gross pay, that's going to be the hours they've worked multiplied by how much they get paid per hour. And of course I cannot calculate the deductions until I know the gross pay. Because let's say the deductions are 20%. Well, it's going to be 20% of the gross pay. So to work out what the deductions actually will be, I need to know what the gross pay is. And of course, to calculate the net pay, I need to know the gross pay and the deductions, because to get the net pay, you take the deductions from the gross pay to give you the net pay. But what I've done here, I'm thinking before I start writing any code of the steps involved. I've got this top level design here, which gives me a rough overview of the bold steps that my program's going to have to take forward, and then I'm refining these steps individually. And I've just shown the refinement of step 3 here. Of course, I might have to refine step 2, and so on. But what we're looking at here is something referred to as stepwise refinement. It's designed by stepwise refinement. You give some bold steps, and then you work on the details of each individual step. And it's a good way in which you can go about designing your programs that you have to write for whatever purpose. These designs can be further represented by a structure chart, which is a non-object orientated technique. In other words, you don't use the structure chart for object orientated programs. If you want to support the design of object-oriented programs, you have to use UML, which stands for Unified Modeling Language. But we'll be covering that later in the playlist. A structure chart supports procedural design. I would like to emphasize the following point. A function is not a technique used for pure object-oriented design. If we're going to design in objects, a method is the name given to a similar technique used to support object-oriented programming. Now, with reference to the program we're concerned with here, well, this is the one where we're actually going to be issuing wage slips. I want to show a structure chart, and I'd like to emphasize this is rather elaborate for such a straightforward program, but we're going to show it nevertheless because it will highlight some of the features we have when we design our programs in a procedural way, with the use of functions to support this particular approach to designing and coding in Python. So we know we've got this need to issue wage slips, and the first thing we need to do is to call a function that I've called getEmployeeRecord. And what this is going to do, it's going to return the record. Now this record is going to be data, and it's going to contain the things that we need, and it could be on a disk. What it's going to have in here is the employee's name, how many hours they've worked in this particular week, how much money they get paid for every hour they work, that type of information. And I know when that data is passed back, what I'm then going to do is to call calculate net pay, and I'm going to send it the record, the information that I've called from a disk possibly, using this function getEmployeeRecord. And what I'm doing here is this is calling this, and this is what this arrow means. It's emphasizing there's a call, and this here is referred to as a data couple. We're passing from here to here the data that this needs to work on. And of course, if we're going to calculate the net pay, one of the first things we need to do is to actually calculate the gross pay. And when I've done that, you can see this is the call, and I'm passing these data couples here, which is the pay rate and the hours worked. Now, where did that information come from? When it came from within this record. So what the calculate net pay has done is extracted the pay rate and the hours worked, and it's passing it to the gross pay module. Now, I called it a module there. What we're looking here at, these are all examples of modules. When we get into the code, we're going to see that we will implement these using functions. But let's get back to this calculate the gross pay. We can see it's been called by calculate net pay, and calculate net pay has sent these two pieces of data. And what calculate gross pay is going to do is going to take this data, multiply them together, calculate the gross pay, and it's going to pass that back to calculate net pay. Now, the calculate net pay function is then going to call the calculate deductions function, passing it the gross pay and the tax details. Now, the calculate deductions is going to use the gross pay data and the tax details data and work out what the deductions are. And those deductions are then going to be passed back to calculate net pay. The calculate net pay function is then going to use the gross pay and the deductions to calculate the net pay. And it'll achieve this by subtracting this data from this to calculate the net pay, and then the net pay is going to be returned to the issue wage slip function. The issue wage slips function then will call display wage slip, sending it the data, name and net pay. And of course the name would have been extracted from the record, and the net pay, well, we've just discussed how that was actually calculated. Let's summarize the usefulness of structure charts. A structure chart can act as a picture of the software parts used to develop the program, i.e. the software system. The structure chart shows all of the functions used to implement the program and shows how data is passed throughout the structure of the overall program, i.e. the overall software system. The structure chart shows the system as partitioned communicating modules that can be separately developed and tested. Now that's quite important. You've seen all those individual modules. Now each one of those, you as an individual can work on each one in turn and get that one working, and then work on another one of the modules and get that one working. Or a team of programmers can all be given a separate module to develop and test. So if you've got a program with 100 modules, then you could give 10 modules to one programmer, 10 to another, and they can develop the functions to implement each of those modules. So you can share the modules throughout a team, or you as an individual can, as I've already said, work on each one in turn. And it gives a structure to the development of the software. All of the complete and tested modules can then be linked together to produce the final program, which after integration testing can be released as the final product. So a structure chart, as well as helping you decompose the problem and break it down into sensible logical units, it can be used to drive the software engineering process of actually building up your software system sensibly. Let's have another quick look at the structure chart again. Here you can see the various modules calling the other modules and the data couples being passed between the various modules. Now, when we're dealing with the structure chart here, we call the rectangular boxes modules, but when we implement this in Python, these modules become functions, and the data couples become parameters to those particular functions. What we have with the structure chart, however, is a way of seeing if we can get a good design before we write one line of code. And you can redraw this in various ways to see if you can get a better design. And the key is what a structure chart allows you to do is to produce a good and well-designed program before, and this is the key, before you write one line of code. Now, this obviously is a structure chart that's a little bit overkill for such a straightforward program as we're discussing here. But I wanted to choose something that gives you the flavour as to what a structure chart was. And to emphasize again that this is a technique that's used for procedural coding, not object-orientated coding. Object-orientated design is supported by UML, Unified Modeling Language. Now let's say we're happy with this design and we go forward with it. What I'm going to do, I'm going to say, right, I'm going to start implementing this. And to do that, what I can do, I can pick on one of the modules and say, right, I'm going to write the code to implement that module. And the one I'm going to choose is this one here, calculate gross pay. And that's the one I'm actually going to write the function for. So let's consider the module in isolation. Here you can see I'm going to call the module calculate gross pay. And I'm going to send it the pay rate and also the hours worked. And what's going to happen, the calculate gross pay module is going to multiply those two chunks of data together, work out the gross pay and send that back. And what this now means, this can now be coded and tested independently. Now a couple of things to do with terminology here. I've referred to the rectangular box as a module, the calculate gross pay module, and the pay rate, the hours worked and the gross pay as data couples. And that indeed is what they are when you're referring to a structure chart. In Python, you're going to see that the calculate gross pay is going to be a function and that the data couples are going to be the parameters that we're dealing with when we implement the module in Python as a function. Now, if I'm going to give this some thought, what I need to do is to say, well, what I need is a module specification for this. And this is the module specification shown here. And you can see that I've got a function name, which should be clearly obvious. It's calculate gross pay. I've got input parameters, which is the pay rate and the hours worked. And I've got a return value, which is the gross pay. And I've also got something called mechanics. Now, for this particular example, the mechanics are straightforward. By mechanics, it's going to be the algorithm. And this doesn't really have an algorithm as such. It has one program statement. And this is the program statement here. Gross pay is assigned pay rate multiplied by hours worked. Now, of course, a proper function would have many more lines of code here, would have a more involved algorithm. That's not to say that you wouldn't find this useful, you might do, but remember this is a teaching video, so I'm trying to keep the algorithm relatively simple for this particular illustration here. And you'll also see I've got local variables. Now the local variable I am going to need is going to be the gross pay, because when I do the calculation I need that to be stored somewhere. So I will declare within the module, within the function that I'm going to write, a variable which is gross pay. And of course that's the thing that's going to be returned. So what we now have, we have this, which is the isolation shown, and that belongs in the structure chart, and we have this module specification here. The way forward now for us as programmers would be to produce a testing program, and we'd arrange for this testing program to call the calculate gross pay function. It's a module as it appears here in the diagram, but remember it would be a function in Python. And we would arrange for the data couple pay rate and the data couple hours work to be sent. Now these would be parameters in the function, or arguments is another name for them. And then the calculate gross pay would work out what the pay rate and hours work were and would return that. And of course we would need to see if we can make sure that the calculate gross pay is working in the way in which we expect it to work. And that's for the purpose of the testing program, which would be used in conjunction with a test plan, which we've covered earlier in the playlist. Now the next video in the playlist is going to show how we implement this particular module, which is going to be a function, in Python. Check out the supporting website for these videos, and also consider subscribing to the YouTube channel and get an automatic update every time I upload a new video. Also consider subscribing to the Google Plus circle that relates to these videos.